Okay, Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, my name is Rifqy Ergiano with name 123490015. And today I will show you Module 5 of Application Counter PLC at the Pneumatic System or Pneumatic Praktikum. We go to the first slide. Here is the objective of practicum, and the first one is to understand the working principle of the counter at the PLC Omron, and then the next one is the second. Number two, to learn the use of uh, CNT, CNR or reset counter, and the variant in a ladder diagram. And the third is the last. The last of the objective is to know how to connect the counter to the output. Okay. And then next is the objective question. Objective question is the first. The first is the what what is the meaning uh, by what is the meaning by the counter in a PLC, and how does it work? Okay, here is a counter in a PLC, and an internal instruction used to count the number of occurrence of specific input signal, such as pulse or activation from sensors or switches. It works by increase or decrease its count value each time the input condition is met. Uh, Once the count reaches a predetermined value, the counter can trigger an output or another instruction. This allows the PLC to perform control operation based on the number of events that have occurred rather than on time or continuous input signal. And then the number two is uh, why why the counter need to be reset, and what is instruction used to do it. Here is the counter needs to be reset to clear the stored count value and return it to its initial state, usually 0. Resetting is important to ensure that the counting process starts correctly for the next operation cycle and to avoid error caused by residual count from previous cycle in PLC. The CNR or counter reset instruction is used to reset the counter, allowing the system to begin a new counting process when required conditions are met. Okay, we go to the next slide. The next slide is the counter up or CNT. This is the instruction. The function is to count the number of rising pulse from the input. The working principle the working principle is the each time an input is active. For example, is when the button is pressed or a sensor send a signal, the CV value or current value will be increased 1. Then the next is if the CV if the CV or current value becomes greater than or equal to PV or preset value, the counter output bit address CXXX will be on. Okay, this is the instruction. And then the counter format. The counter format is here, the CNT or counter up, and then 0000 the address, and then hashtag 10 for the value of PV. Then the next is CNTR or counter reversible or bidirectional. The function the function is count to count both upward and downward depending the input condition. Okay, the working principle is when the input up when the up input is active, the CV or current value will be increased, and when down input is active and the CV will be decreased. Okay, and then the next is the output turn on when the output turn on when CV is decreased from the VV, then turn off again when CV falls below PV. And this is the instruction. And then the counter format is CNTR or counter reversible. And then the address is 0001. And then the value PV is the stack 10. Okay. And then the next is the ladder PLC. This is the ladder PLC from CX programmer. And then here, right here, the first picture is shown the counter up circuit on the left here, right left here, and then for the reversible counter on the right here. Both are designed using Omron PLC software that now we use is the CX programmer to demonstrate how counters work in practical application. Okay, the CNT counter up circuit on the left side. In this circuit, the CNT instruction is used to count how many times the input switch is active. Right here, when the input, uh, when the input right here 002 is pressed, the counter or CNT 000 start counting each activation, and every time the switch turn on, the current value or CV increase by 1. When the counting reaches the present value or PV, which is the defined as hashtag 10 to counter output C000 turn on. The timer at the T000 is also used to create a delay or control timing before resetting the counter. Once the counter reaches its preset value, the output coil here, W006 is active turning on and connect the device such as a lamp or any indicator. And then for the next is the CNTR circuit right here. This circuit show the use of CNTR or reversible counter instruction, which can count both upward and downward depending on the input. The input is the here T E I003 and where is the 003 serve as the up and down counting triggers. When the sensor 1 here the 003 okay is active, the counter increment the count, and the timer T0001, the timer reset 001 is again used to reset or control timing between counts. When the current value or CV becomes equal to or greater than the preset value or PV, which is set as hashtag 10, the counter output C0001 will be turned on, and the final output is the here W007 is active when the counter condition is met. And next, okay, next we go to demonstrate the how to make this ladder PLC on the CX programmer. Okay, thank you. Okay, and now we go to the CX programmer here. Here we make a new file, uh, module 5. Okay. Okay. Now I will demonstrate how to make an circuit PLC at this CX programmer like this this picture. Okay. Now just watch. First we get a new contact here, and the address is the 000, and then the command is push button on. Okay, and then here close contact is 001, and then the command is off. Okay, next it's some horizontal. Here add some new coil for the system is the 000. Okay, and then next is the for the system. Okay, the above of the PB on. Here we get new contact again. Is the for the system. The address is W000. Okay, disconnect it with the vertical. Okay, this is the first for the system. Then next we add some this CNT or counter up circuit. Here we add some CNT switch, and the address is 002. It's for CNT switch. Okay, here at some the system. Okay, then we add some for wait for second, add some new contact. Okay, new contact is okay. Let's go 1 second. Okay, 1 second, and then just connect to yeah, what's the instruction? The instruction is CNT 000 for the address, and the value is hashtag 10. Okay, is counter or CNT. Okay, and then the next we had some nickel under here. For the time is T000. Okay, this is time set. Is it okay? It's empty. Next we add some here, a new horizontal. and then and here here it's for the counter up, see 0 0 0 0, okay, for counter up. Okay, and then next add some new horizontal. The new horizontal is for the time. The function is thing 0 0 0 0, and then the value is 50. Okay. Okay, for the time reset NT. Then next the under here add some new coil for the CNT. W 0 0 5. Okay, this is CNT. Okay, okay, then we make some the CNTR, the CNTR. Okay, okay, and then let's this programmer. The coil here, the address is 003, 003, and then this is for switch CNTR, CNTR. Okay, then add some new coil again for the system. The system is the 00 W 00. Okay, then the next is for the sensor. We use two sensor for W3 and 2 address. Add some new coil here. Address is 3. Okay, okay. It's for the sensor. That's it. Alright. Okay. Sensor or PV1. Okay, the under here some sensor again, and the address is W003 and then 2. Okay, this is for the sensor or PV PV2. Here, and then we add some time reset. Time reset is T 0 0 0 0. Okay, 1. So for okay, this is for the time reset. Um, okay, time reset. Set. Okay, time reset and and just connect these two PLC instruction. Here is the for CNTR. Okay, then the next is 0001, and then the next is hashtag 10. Set. Okay, here we add some where is it? Okay, here uh The command is NTR. Okay, then just connect it with some horizontal. Okay, one, two, three, and then we need one more for the CNTR contact. See 0001. CNTR. Okay, disconnect it to the um, yeah, new instruction. Let's see for the delay. For the time, name address 001 hashtag. Okay, time reset CNTR. Okay, this is the circuit of CNT, and this is for CNTR. Next, the last circuit is here for system, and then CNTR. The address is W005. Is it? Eh, no, for CNTR. 3. No, no. Oh, just make it. Okay, this is for CNTR. Okay, here is for CNT. 6 for CNT. Oh, 0. So, so just skip. Yes, delete. Here, some 005. Okay, here is the CNTR that I've been looking for. Yeah, there is 6 for CNT. Okay, then under this two, the uh, the reverse of the two function. Here is for CNT. We add some 006. Okay, and here for hmm no. Here 6 for CNT. And then here is wrong too. That's for CNT 006. Okay, now just connect it to the new coil or for the output. This the address is 100 07. No, 100 not 7. Command is output. Okay, the circuit is ready for the ladder PLC of CNT and CNTR. Now we just work it online. Use this option here, work online simulator. Just click the data will transfer to the PLC. Okay, now we can see here the time is counting, and then if we turn on this one, okay, the system will on. To open the turn on the switch, just click on here, here, yes, and okay, okay, and then if we want to reset the system, just click here. One, the time will be stopped and reset. Okay, we go again. So the time will run again here and here. If we want to connect this for the sensor 1, the sensor 2, the system will be running again. Here too. And the reset. No. Okay. Here too. Okay, the system will on. Why this is the not for this? Okay. Okay, now I think just that's it. To switch off, just switch this one. The system will off. All of it. All of the system will off. Okay, I think that's it. Just that of my video. Thank you for watching and see you in the next video.